Dimensional analysis. Now, here's a technique that I don't want to skip over or go over too quickly. I want you all to not do it either. Incredibly important. Very, very important for chemistry. Many of the problems that we're going to see both in this semester and the next semester rely on you being able to do dimensional analysis. If you master this technique, you'll be able to do those problems just fine. If you struggle with it now, you'll struggle with it then too. You got to master this, okay? So I don't care how long it takes, how many practice problems you have to do, get it down. Trust me. Alright, so what is dimensional analysis? It's analyzing a problem by looking at the dimensions. Or maybe unit analysis might be a better or another way to describe it, by looking at the units of what you have. A very simple way to introduce this idea is by doing a conversion. Okay. Of course, I know there's 12 inches in a foot. Right? And if I said, okay, well, you got 3 feet. How many inches do you have? Well, if there's 12 in each one, I've got 3 of them. 3 times 12, 36. I got 36 inches. Most of us can just do that in our head. We don't even think about how did we actually do that? Why did we know we multiplied and not added or subtracted or divided or something? Most of us have a sense of that. Okay? But when we get to these more complicated problems, you're not going to have a sense of it. And you're going to have to be able to sit down at the paper and figure it out. Dimensional analysis makes it easy. Trust me. So get this down. Let me do it. First this example in my notes, and then we're going to move on and do some of the practice problems in the chapter as well. Okay, and then I'm going to come back and talk about these conversion factors here. So, for example, convert 34 inches to centimeters. Now, again, if it was to yards, maybe I could figure that out a little bit because I know 12 inches in a yard. But centimeters? Centimeter. I would have to know how many centimeters are an inch, or how many inches are in a centimeter, and then I'd have to figure out, do I multiply or do I divide? I mean, how do I go about that? Okay. Well, first of all, let's look up on this table. I guess I'll get to this sooner than I thought, right? Here's length. If I look in here, 1 inch is the same thing. It equals 2.54 centimeters. Exactly. So there it is. That's like saying 12 inches equals a foot. Right? That kind of an idea. So 1 inch, 2.54 centimeters. There's my conversion factor. That's what I'll have to use. Now, how do I convert 34 inches to centimeters with dimensional analysis? Well, let's start with what I know. 34 inches, I read it down. Right? Very important with dimensional analysis, you always have a top and a bottom. I kind of think of this as a fraction. So 34, I can put any number over 1. There's my top. My bottom is just a 1. Right? Always set it up that way. Right? You're always going to have. Now, sometimes you're going to have actually a number on the bottom or something else on the bottom, but in this case, there's just a 1 down there. Okay, so 34 over 1. Now, the idea here is as long as I multiply this quantity, which I'm calling 34 inches, by the number 1, then I will not have changed the quantity. Right? You can multiply a number by 1, it's still the same number. Right? 17 times 1 is still 17. Of course, the number 1 doesn't have to be written as a 1. What if I said 5 over 5, a fraction? 5 on top, 5 on bottom. Well, that's the number 1, right? So 17 times 5 over 5, still 17. Okay. Here's the trick. With dimensional analysis, the number 1 we're going to choose has different units on the top and the bottom. Now, didn't we say up here 1 inch is the same thing as 2.54 centimeters? Yep. So they're the same. 1 inch on the top, 2.54 centimeters on the bottom. That's the same, top and bottom. That's the fancy version of the number 1. And so if I take a measurement and multiply it by that, I'm not changing how much that measurement is, but I will change the units that we describe it with. Okay, so go back to here. Again, 34 inches over 1. I'm going to multiply it by the number 1 here, 2.54 centimeters on top, 1 inch on the bottom. That's the number 1, a big fancy number 1 in parentheses. Now, I could have done it the opposite way. I could have put inches on the top and centimeters on the bottom. Why did I choose it this way? Because I'm trying to convert those units. And I also know a rule about fractions. If I have the same thing on the top and the bottom, they cancel each other. I have inches that I'm starting with on the top. So you know what? I'm going to put inches on the bottom here. That way they'll cancel. If I put the inches on the bottom, then I guess the centimeters are going to go on the top. And when I multiply this all out, those 2 inches, top and bottom, will cancel. The centimeters don't cancel with anything. There's no centimeters on the bottom, so they'll remain. Okay, so I'm going to multiply this by the number 1. All right, so I set it up. My inches cancel out, and there we go in green. My centimeters don't cancel, so that's why my answer is going to be in centimeters. Okay. And what about the numbers? Well, anything on the top, anything at all, you're multiplying it by. Anything on the bottom, you're going to divide by. So in this case, 34 divided by 1 times 2.54 divided by 1. And you would just do this in your calculator, put that through. Turns out to be 86.36. Significant figures though. I'm doing a bunch of multiplying and dividing. What's my weakest link? The number ones are not your weakest link. This isn't a measurement, this number 1. It's an exact number. 1.000000, I mean, for an infinity. This is not your weak link. Exact numbers have an infinite number of significant figures. All right, you want to look at the actual measured things. All right, 34 inches. Okay, there's 2 significant figures there. 2.54, 3 significant figures there. All right, and actually they said it's exactly 2.54, so technically there's a bunch of zeros out there, so that has an infinite number. Either way, 2 significant figures is my weak link. And so this I need to round off to 2, so that's going to be 86. 86 centimeters. Who knew? 34 inches, the same thing as 86 centimeters. Okay, but you see how we set that up? I used the fancy version of the number 1. I used the top and the bottom from a conversion factor type of a table that you look up in your textbook or on Google or something like that. Okay, and you set it up so that the units cancel. The units that you want to get rid of, the units you want to end up with, don't cancel. All right, so let's look at another one, a little more challenging one here. Antifreeze. You put it in your car, keeps your car cool, the radiator. What's the density they're asking here in terms of grams per milliliter? They say, hey, you can buy a 4-quart bottle of this stuff and it weighs 9.26 pounds. They want me to figure out the density in grams per milliliter, and this is what they give me? Not so hard, really. First of all, I got to remember density is mass divided by volume. And they gave me a mass, 9.26 pounds, and they gave me a volume, 4.00 quarts. All right, so mass divided by volume. There, I've just put it in. 9.26 pounds on top, 4 quarts on the bottom. That technically is the density right now. It's just it's in the wrong units. I've got it in pounds per quart. They want it in grams per milliliter. All right, so now I just do the conversion. Let's do the pounds first. If I go up here to my table, I'm talking about mass here. Let's see, what do we got here? Pounds to kilograms. 453. Oh, I'm sorry. I read that wrong. Pounds to grams. Okay. I was like, how did I set that up? I just read the table wrong here. 1 pound is the same thing as 453.59 grams. There's my top and there's my bottom. Whichever way I need it to go, top and bottom. 1 pound, 453.59 grams. All right, so I look at here. Pounds are on the top of my fraction. Again, notice there's a top and a bottom. This one actually does. I didn't have to put it over number 1 because there really is a bottom to it. Okay, so I'm going to put the pounds on the bottom of my first step there. That way they're going to cancel. 1 pound, it said, was 453.59 grams. That's the top. That's the fancy version of the number 1. I'm not going to change it. All I'm going to do is convert the units. Pounds are going to cancel. Grams don't cancel. Hey, but that's good because I want to put the answer in terms of grams, and now I've got it in terms of grams. If I stop my calculation here, I'd have grams on the top and quarts on the bottom. All right, so grams are taken care of. Now I got to do something with this quarts. So again, I want to convert it to milliliters. I go up here, volume, 1 liter is 1.0567 quarts. The only thing with milliliters here is to tablespoons. All right, so I don't have the exact conversion here. I'm going to have to be a little more clever. All right, well, here's a quart anyway. A quart is the same thing as 0.94635 liters. Okay, and so I could do that one here. See, 0.94635 liters is the same thing as 1 quart. Notice I put the quart on the top when I set this up. Why? Because my quart of the original number is on the bottom, and I want it to cancel. I don't want quarts, right? I want to convert it to milliliters eventually here. So quarts on the bottom initially is going to cancel with my quarts on the top here. All right? So that's why 1 quart was on the top. The 0.9465 liters is on the bottom. All right, quarts cancels now, and I'd be left with liters. So if I stopped at this point, I'd have grams on the top and liters on the bottom. It'd be grams per liter. Well, that's closer to what I want. I don't want liters, I want milliliters. Oh, milli is just 1/1000th. There's 1,000 milliliters in a liter, right? And so there's my last step here. Liters on the top, so it cancels with that one on the bottom. milliliters on the bottom. Right? And again, in a conversion table, I don't need to go look that up. I know it. I know what milli means, right? 1/1000th kind of thing. So I know there's 1,000 milliliters in a liter. There's my numbers. I put them in. Right? Liters cancel. Now, if I stopped here, I'd have grams on the top, milliliters on the bottom, which is exactly what they asked me for. All right, so I put my equal sign. I know my units are going to be grams per milliliter. And finally, as the very last step, finally I will pick up my calculator and punch the numbers through. All right? Don't pick it up right away. Set it up. Look at those units, the dimensions. We're doing dimensional analysis. You're analyzing this by its units. It's a very powerful technique. All right, so now that I got it all set up, I pick up my calculator and I punch the numbers through. And remember, everything on the top you're multiplying by, everything on the bottom you're dividing by. That's what fractions are, the top divided by the bottom. So in this case, I got 9.26 times 453.59 times 1 times 1. Right, now you're going to go back through, divided by 4, divided by 1, divided by 0.94, divided by 1,000. Okay? And it doesn't, you can do all the multiplication and do all the division, or if you want to do this, multiply, divide, multiply, divide. No, it doesn't matter. You can change the order of multiplication, division. It doesn't matter. Right? That's one of those rules of math. Put it all through on your calculator, and it spits out 1.10959. Okay, write that down, 1.10959. I know my units are grams per milliliter. The last thing to check, what about sig figs? Right? I can't report more on the answer than I really have. All right, back here, I got 3 here. I've got 3 here. All right. That's an exact number. I've got 5. An exact number. I've got 5. An exact number. Exact number. Sounds like 3. 3 sig figs. So I need to round off my answer to 3. That gives 1.11. All right. So I'm going through that really slowly, explaining each and every step. You're looking to cancel those units. You're looking for fancy versions of the number 1 where it's the same top and bottom. And then everything on the top you're multiplying. Everything on the bottom you're dividing. All right, so this antifreeze is 1.11 grams per milliliter. By the way, compared to water, water is 1.0 more or less, and so it looks like antifreeze is just a touch more dense than water is. Okay, let's try some extra practice problems from the textbook. Again, I really want you to see enough of these to get this technique down and down well. So let's see, example 1.8 from the text. The mass of a Frisbee is 125 grams. Convert that to ounces using the unit conversion factor. 1 ounce is 28.349 grams. Now, I wouldn't have known that off the top of my head, but they told it to me. Apparently, it's also in table 1.6, so it's good. I can go ahead and use that. So get a scrap piece of paper up here and let's write this down. All right, we're starting with something that's 125 grams. And then they also told us, or you could find in the table, that apparently 1 ounce is the same thing as 28.349 grams. Great, so there's my conversion factor. That's going to be the top and the bottom of my fraction. I start my calculation off with the amount that I have, 125 grams. Remember, everything's a fraction. Everything has a top and bottom. I'm going to go ahead and put that over the number 1. All right, now we convert. Grams is on the top here. That's what I want to cancel, so I'll put it on the bottom. Top and bottom cancels. I'm converting from grams up in my conversion factor to ounces. Can put that right there. And the numbers, looks like the top is 1 for the ounce and 28.349 for the grams. Again, that comes directly from the conversion factor. You can see over here, now my grams on the top and bottom cancel, like that, which means my answer is simply in ounces. And now I can go to my calculator and punch this through. I'm starting with 125. 125 divided by 1. Don't really need to put that on my calculator, right? The next part, times 1. Again, don't need to put that in, but then on the bottom, divided by 28.349. Okay, so divided by 28.349 equals 4.40932. Okay, let's write that down. 4.4093266. Okay, I know all of those numbers are not significant. Let's go back over here. My ones are exact numbers. Don't need to include those. This is 5. Here's 3. So I guess 3 significant figures is what I've got. And so that's rounded off to 4.41 ounces. All right, simple, quick and simple. Let's try another one. Maybe one that's a little more challenging. So, oh, by the way, let's see. They also, 4.41 is what they also got. So that's good. 1.9, let's go for 1.10 here. It says, while driving from Philadelphia to Atlanta, the distance of about 1250 kilometers, a Lamborghini used 213 liters of gas. Okay, I think first I'm going to start just by writing down that information that I know. Right, so scrap piece of paper. I know that the distance was 1250 kilometers, and it used up 213 liters of gasoline. All right. Next, let's see, what is it asking me to calculate? What average fuel economy in miles per gallon? So miles per gallon, that's miles divided by gallons, or in other words, miles on top, gallons on the bottom. Right? So miles per gallon, did it use during this trip? All right, so they want miles per gallon equals what? All right, well, miles is distance on top. Gallons, that's the volume on the bottom, and I've got those two things, except I don't have distance in terms of miles, I've got it in kilometers. I don't have volume in terms of gallons, I've got it in terms of liters. But I still have it, it's just a matter of converting it. So let's go ahead and write that down. The fraction of this fuel economy or fuel efficiency is 1250 distance over 213 volume. Kilometers per liter. Now we just need to convert that to miles per gallon. All right, we do that the same way as always. Kilometers to miles. Notice I put the kilometers in the bottom, so it's going to cancel, and miles, therefore, will not cancel on the top. Let's go back to our table and see if we have anything on the length for miles and kilometers. And there you go. 1 kilometer is 0.62137. 0.62137. So let's go ahead and write that down here. I'm going to write it off to the side here. This is just things I know. I know that 1 mile is 0.62137, was it? 137 kilometers. Let me just double check that. 1 kilometer is 0.62137 miles. Well, that would make a difference, right? So that is not what I meant to do. 1 kilometer is 0.62137 miles. So there's my conversion factor, and that's what I can use then in that step right there when I go from miles and kilometers. Let's see, what goes on top? The miles is on top, so the 0.62137, and the bottom is the kilometers, which is a 1. The kilometers cancels, and if I stopped my problem right there, I'd have miles per liter. But I don't want to stop there. I want to keep going. I want to convert liters now to gallons. Alright, so liters I'm going to put on the top so it will cancel. And let's go back to that table. In the volume, well, I don't have gallons anywhere on there. I do have liters to quarts. 1 liter is 1.0567 quarts. Alright, so I'm going to have to do this in 2 steps actually. Liters to quarts is on that table. It said 1 liter is 1.0567 quarts. Let me double check that again. Yeah, 1 liter is 1.0567 quarts. That's correct. Alright, and so now liters on the top cancels with liters on the bottom. There we go. And if I stop now, it would be miles per, say miles here per quart. I don't want per quart, I want per gallon. So my last step, quarts on the top, so it'll cancel, gallons on the bottom, and I know that there are 4 quarts in a gallon, just like 12 inches in a foot sort of a thing. Quarts and quarts are going to cancel. There we go. And now if I stop here, put my equal sign, the top will be miles, the bottom will be gallons, which is exactly what they want, miles per gallon. So finally, after setting it up, making sure everything cancels correctly, getting the final units, now, as a last step, I'll go over to my calculator and we'll put the numbers through. 1250 on the top, divided by 213 on the bottom, times 0.62137, on the top, divided by 1. Right? Then the next step, times 1, but then divided by 1.0567. Right? And then finally the last step, times 4, and then divided by 1. So equals, there's my answer, 13.803492. Alright, sig figs again, look at 213 is 3, 1250 is also 3. This has 5, 5. These are exact numbers, so they don't count. So it looks like 3. So I want to round off 13.8039 to 3 significant figures. That will be, of course, 13.8. So 13.8 miles per gallon. Yeah, that Lamborghini didn't get very good gas mileage, did it? Let's just check that number with the book. See if we get the same thing. Yeah, there we go. They also got 13.8 miles per gallon. Alright, let's see. There's a part B to this as well. It says if gasoline costs $3.80 a gallon, what's the fuel cost of the trip? Alright, so $3.80 per gallon. That's another conversion factor. It converts between gallons of gasoline and dollars for that gasoline. And I got to think about it that way. It's just another conversion factor. So let me write that down actually. It's $380 is the same thing as 1 gallon. And there's my conversion factor, right? And so it wants a total cost of the trip. Well, let's see. We want 1,250 kilometers. How am I going to do that? I want to convert kilometers, put that over 1 because it's a fraction, kilometers to dollars. Well, I can get to dollars if I know gallons, right? From here to here, I need to know gallons. Can I go from kilometers to gallons? No, but I can go to miles. Miles to gallon, I just figured that out. It was 13.8. And I can go to miles here from kilometers, so I think it's a 3-step conversion. First step, I'll put on the bottom kilometers, so it will cancel. We're going to convert that to miles. I know we can look that up, we just did before. And then I can go from miles to gallons of gasoline, because again, that was 13.8, we just figured that out. And then finally here, I can go from gallons of gasoline to dollars, because it's $3.80 per gallon. Alright, so let's just fill in these numbers. First of all, miles to kilometers, we did that before. It's right here, that conversion factor, and it's in the table. 1 kilometer is 0.62137 miles. 1 kilometer is 0.62137 miles. Kilometers cancel each other. The next one's miles to gallon. That was 13.8. We just figured that out right there. Alright, so 13.8 miles for every 1 gallon. 13.8 miles for every 1 gallon. Miles cancels. And then finally here, gallons to dollars. Well, let's see, dollars, $3.80 for every 1 gallon. So $3.80 on the dollars, that's the top part. 1 on the gallon, the bottom part. Gallons, top and part, bottom will cancel. And so finally, I can put my equal sign. Everything cancels on my units except for dollars. That's good. That's what I wanted. And now I can finally go over to the calculator and punch that through. Alright, so let's give that a try. 1250 divided by 1, okay, times 0.62137 divided by 1 times 1 divided by 13.8, and then here times 380 and then divided by 1. So it looks like I'm getting 213.877355. Alright, sig figs, I've got 3 here. Here I've got 5, I've got 3 here as well, so I would round that off to 3, so that would be $214. $214 is what he would spend on money for fuel. Let's check that against what they calculated. Yeah, sure enough, 214 is also it. All right. Dimensional analysis. These are fairly simple problems here, but again, as we go into additional chapters, we're going to be using this left and right, so make sure you get it down.